Okay, for the quotient rule. Remember, take these notes. Don't just watch the video. You can pause it when you need to catch up, to write. This is the quotient rule for exponents. Now, the word quotient is really division, right? That's a fancy word for division. This is the word, this is the rule we're going to see that when you're seeing exponents, it's like the division rule, the quotient rule. Okay, so we're going to take what we understand so far about exponents and we're going to apply it here, right? So we know that m to the power of 5 is the same as, right? We know an exponent, right? This is your exponent. That means that this base is being multiplied to itself. How many times? 5 times. You understand that? Okay, we've done that. And even if it's a number, 2 to the power of 4, you understand that that means 2 times 2 times 2 times 2, right? You're going to multiply this to itself 1, 2, 3, 4 times. Okay. What you're going to have to understand and apply now is this. Let's say if I have x to the power of 6. Yes, that means x times x times x times x. 1, 2, 3, 4. Yes, that means there's 6 of them. There can't be more than 6. There can't be less than 6. But there's a way to write x6 as a product of 2 of them, which you've been doing for the product rule. Is it true that I can say that 2 of these, which is x squared, and multiply it to these other ones? Would this be true? Would x6 be x2 times x4? Yes. Because the product rule says that if you multiply these, remember, add the exponents. If this adds up to 6, it's right. x6 can be written as x2 times x4. Right? You can also write x6 as what? x4 times x2. Because we're going to keep the base, and when you add these exponents, see 4 plus 2 equals 6. As long as it adds up to this, you're fine. It's going to be okay. Can you write x6 another way? Well, what if I change this to 3? If I use 3 of these, if I'm using 3 of these, how many more do I need so that it adds up to 6? Well, you agree that if I have 3, then I would need 3 more? Yeah, because 3 plus 3 is 6. This is a good statement. This is correct. I'm rewriting x6 as the product of these two. It's still right. And can I write x6 another way? I use 2, I use 3. How about if I use, oh, we already did. How about I use x6 is equal to, what if I just have one of them? x1 times how many more x's? If I have 1 here, and I have to get up to a total of 6, how much more do I need to add here? Remember, these add up. These add up to give me 6. 2 plus 4 is 6. 3 plus 3 is 6. If this is a 1, what would I need here? 1 plus how much to give you 6? 5, right? All right. This is also a true statement. I can write x6 as a 1 times a 5 because these add up to a 6. Look at the exponents. And even though we haven't talked about it yet, you can even have 0. 0 is an exponent. That means I got no x's there. So if I don't have any here, how many do I need here to get me to 6? Well, obviously 0 plus 6, right? Okay, you're going to be using this same understanding. You can use the same understanding for the quotient rule. All right, so we said quotient. The word quotient means division. And what we're going to use is the easiest concept of division to make this work easy for you. What's the easy concept? Example. Division is like 2 divided by 2. That's the easiest one. When I have the same number divided by itself, 2, how many times a 2 goes into itself? Once. We know the answer is 1. Right? When I can get the top and the bottom numbers to match, I know the answer is 1. We say that they divide out, and your answer is 1. All right? And that's true for any number. If I have 8, 8 divided by what? Well, 8 divided by 8. If I get the same number on the top and bottom, I know my answer is what? 1. You guys agree with that? That's what we're going to be using, right? Because 8 divided by 8, they divide out, they cancel out, you're left with 1. Well, the same is true for variables. If I have m divided by m, guess what's the answer, everybody? 1. Because they divide out. They cancel out, you get 1. And I can even have, I mean, it doesn't matter. You can have, what if I have x4? What would I need to have here? Also an x what? x4. Because if there's 4 of them here, and then there's 4 of them down here, they all cancel each other out. And when they divide out like this, just the way you understand, 2 divided by 2 is 1. 8 divided by 8 is 1. I have the same amount here divided by the same amount, which is the same thing you're seeing here and here. The answer is 1. That's what we're going to use. We're going to try to get the same numbers to match on the top and the bottom, so they divide out, and I know that part gives me 1. All right, now let me tell you how you're going to do that. You're going to have eventually problems that are going to end up like this. Number 1. What if you have x2 times x3 over x squared? Well, look. These match. If I got the same thing on the top and bottom, they give you 1. Or we could just say the divide out. And 1 times this x3, well, you're just going to be left with x3 over 1. Well, when the ones on the bottom are nothing's left, the answer is just x3. See, we're going to try to get the same amount to match on the top and the bottom, and they divide out. Let's look at a similar problem. Very similar problem. What if I have x2 times x3 again? But this time, instead of having an x2 in the bottom, what if I have an x3? Well, this one doesn't match with this one, right? Which ones are going to match and divide out? These are exactly the same and divide out. So that's x2, x3, and then with the x3, this divides out. What's left? I mean, we say it's a 1. 1 times x squared is just going to be whatever's left, right? The answer is what? Just the x squared that's left over. I mean, you could put a 1 if you want. You could put a 1, but we don't need to. All right. And it's the same thing for numbers, right? If I have 5a squared b over 5 b, well, which ones are the same on the top and the bottom, and they can divide out? The 5 divides with the 5. 5 divided by 5 is 1. It goes away. And the b's, right? The b's are the same. They cancel out. They divide out. What's the answer? Whatever's left over. A squared. Okay. It's not going to be that easy. Now, let me tell you how it gets a little tricky. Here's where it gets a little tricky. Number 4. They're not going to match. Not initially. M6 over M4. See, they don't match. So what you're going to do is you're going to look at the lower, the smaller number. Obviously, the exponent, right? The 4 is the least. This one cannot go greater than 4. But I know this one has 4. It has 1, 2, 3, 4. It has 1, 2, 3, 4, 5, 6. It has more than 4. So you're going to keep the lower one, keep the smaller one, and just write that one there. And if it has 6, I know it has 4. And your job is to actually break this up. You're going to split this one. You're going to split this one and say, okay, I know 6 is 4, and how much more? See, you got to figure out how much more. This one's M4. We want to keep the lower one. And then we're going to copy the M4 here. And then, because we want these to match. And then 4, and how much more will give you the 6? See, remember these exponents have to add. That would have to be a 2. See, 4 and 2. I'm rewriting the M6 as 4 and 2. Why are you doing that? Because now when you look at this, we want these to match. We want the 4 to match with the 4 up here. I couldn't write this one as a 6 because it doesn't have 6. You start with the lower one. So now these will cancel. You're left with your answer right there, m squared, m to the power of 2. All right. Now, let me try it another way, number 5. Now you gotta watch out when the variable or the parts that are left over on the top, okay, that can be the final answer. But when it's left on the bottom, you can't do that. What if I have M9, oh no, I wrote that wrong. Sorry. Oh, that's okay. I can make this M12. That's okay, M12. So we want to keep the one that has the least. This one has 9 and more than 9. So we're going to keep this one as M9. And this one I'm going to split into M9 and M how much? It has 9. It has more than 9. 9 and how many more to give you 12? Well, 3, right? Because 9 plus 3 is 12. So this is the one you're going to split. You're going to rewrite. You keep the smaller one, leave the smaller one, and then you're going to use that same number here, 9. You're going to kind of like break it up into 9, 9, and how many more to get 12? 9 plus 3 is 12. Okay, then these match and they divide out. And see, when the leftover is on the top and there's nothing left on the... See, this gives you a 1. When there's nothing left, you don't put a 0. You put a 1. And this M3 is in the bottom. Keep it on the bottom. When it's left over on the top, you can leave it like that. But when it's left over on the bottom, you got to put a 1 on the top. Okay. Let's look at another one. Number 6. What about P8? P5. I want to keep the lower one, P5, and I want them to match at P5. So this one's going to change to P5, and I got to add more to P5 to get to this 8. How much more do you need to add to the 5 to get to the 8? 5 plus how much to give me the 8? This has to be equivalent. That's 3, right? 5 plus 3 is 8. I'm rewriting this P8 as a 5 and a 3. Why a 5 and a 3? Because I had a 5 here and I want these to match. Now they're going to what? Cancel out. This P5 and this P5 cancel out. You're left with the P3. And that's your answer. Okay. Now you're going to have 2 variables. What if you have A4, B2 over A, B7? Well, let's make sure they all have numbers, right? If it doesn't have a number, you know if it doesn't have a number, you put a 1. Okay, the A's are going to work with the A's, the B's are going to work with the B's. So there's kind of like 2 separate little problems happening here. So let me look at the A's first. Let me just focus on the A's. I want them to match at the A1. A1, and this A4, you're going to also write a A1, but that's going to be A1 with how many more A's does it need? This 4 is going to turn into these 2. But that would be 1 plus how many more? 3. See, this is the same as the A4. And then I know these are going to cancel. And now I'm going to do the B. We want to keep the lower one, so keep the B2, and then this 7 is going to be a B2, and I'm going to add how many more, right, do I need to add to 2 to get to a 7? Well, this gets split. The B7 gets turned into a B2 with a B what? 5, right? A 2 and a 5. 2 plus 5 is 7. And we did that on purpose, so these can now cancel. So now you tell me what's left over. What's left over here? Only this one. A3 and B5. Okay, last one. Now you're also going to have whole numbers. Whole numbers, something like, let's say I have a 10 and a 2. Those are whole numbers. Those are not exponents. A 10 and a 2, and I'm going to have y8, y4. Okay. We can actually do this the same for the numbers, but numbers are not adding. Remember, numbers are multiplying. So the 2 I'm going to keep. 2 is 2 times 1. And 10, I can write it as 2 times what? Here's my 2. Here's the 10. 10, the bottom one, I can write as 2 times 5. And what do I know? These match, so they cancel out. 2 over 10 reduces to 1 over 5. 2 is 2 times 1. 2 is 2 times 1. 10 is 2 times 5. And see, the 2's cancel out. These big numbers, the integers, is the regular way that you simplify. But the variables, these here, are not going to be multiplied. We keep the smaller one, y4. And this one here is the one we're going to break up. But I want to use what? A y4 here. And you got to ask yourself, if I break this 8 into a 4, how many more do I need to add to 4 to get to 8? Well, that'll be a 4 and a 4 more, right? Because 4 plus 4 is 8. Yeah, of course. This together is representing the y8, but I'm purposely splitting it up like this so that these can what? This one and this one cancel. If this was a 3, I would have put a 3 here, I would have put a 3 here, and then it would have been 3 plus 5, right, to make it an 8. All right. That canceled, that canceled. What's left? 1 y4. 1 times y4 is just y4. And what's left here? Just the 5. The 5 stays on the bottom. Okay, there it is. Good luck with the assignment.